right, this is Macroeconomics, Economics 2301, and we are going to talk about the appendix to Chapter 2. All right. The appendix to Chapter 2 talks about different ways that you can represent data. You can use line graphs, you can use bar charts, you can use pie charts. But the easiest way to represent data when you have only two variables, like we will have in this course, for example, x and y, is a line graph. And when you've got a line graph, you've got two axes here. This one's called the this one's called the horizontal axis. This one's the vertical axis, and we've got the origin here. And when we're talking about the horizontal axis, the numbers increase from 0. So we've got, for example, 1, 2, and 3. And same on the horizontal axis. We start at 0, and it's going to increase as we're going up. So 1, 2, and 3, like that. Well, let's pretend we had some data here for x and y, these two variables. So we'll just keep it really simple. So both x and y are increasing, and they're going to increase just the same, 1, 2, and 3. And for y, we've got 1, 2, and 3. Well, to get this information on a picture, on a graph, what you do is you take one point from x and y. So we've got 1, 1. So what you do is if we put x over here on the horizontal axis and y here on the vertical axis, we're going to find where x is 1, right here, and where y is 1, right here. And both of them together being 1 is represented by that point. Okay, the second point is 2 and 2. So we've got x is 2 and y is 2 right there, and then 3 and 3 right there. If you were to connect the dots, we've got a line that is what we would call upward sloping to the right. And what do we call it when we have two variables that are moving in the same way? They're moving in the same direction. So they're both increasing 1, 2, 3, 1, 2, 3. What kind of relationship is that? A direct relationship, or there's another word for it.
Linear?
Well, it's, yes, definitely a linear relationship. What kind of linear relationship? Positive. Okay, so a direct or positive relationship, this is what it looks like. But the definition of it is when two variables are moving in the same direction. Instead of x and y, a real-life example of two variables that have a positive relationship might be height and weight. So you think of as a little baby gets bigger and as they get taller as a child, they're going to weigh more, right, than the 7 or 8 pounds that they weigh when they're born. You might think of things that go together, like peanut butter and jelly. If people usually eat peanut butter and jelly together, if they're going to be buying more peanut butter, and jelly goes along with it, then they might be buying more jelly at the same time. So those two things are moving in the same directions, right? Those two variables are both increasing. Excuse me. So let's talk about some different variables now. Instead of x and y, let's put price and quantity here. And let's pretend that we're talking about t-shirts. So school's about to start. You need some new t-shirts for the beginning of school. Your other ones are looking a little worn. Let's just pretend you're at the store and there are t-shirts that are $20. Okay, and we're going to pretend it's tax-free weekend. going to draw an axis over here. We're going to put price over there on the vertical axis, and we're going to put quantity over here on the horizontal axis. If you only had $20 to spend, and t-shirts are $20, how many can you buy? Just one. Okay, so these are t-shirts that we're talking about over here. Remember, this is 0. If the price is 20, that's going to be way up here. And 1's just going to be right there. So that represents that point. If you only had $20 to spend and t-shirts were $20 a piece, remember this is price per unit, or t-shirt in this case, right? You can only buy a total of one t-shirt. Okay, if they were $10, how many could you buy? 2. So at $10, you can buy 2 t-shirts. That's represented by that point right there. And if they were on sale for $5 a piece, you could buy 4. So here's 4, here's $5. And then if you connected the dots, our line looks downsloping, right? Downward sloping to the right. Remember when we had a positive relationship, the line went that way, right? Now when it goes this way, what kind of relationship do we have now? A negative relationship, or you can call it an inverse relationship. We have an inverse or negative relationship. It's when two variables are moving in opposite directions. Okay, remember X and Y before? They were both going up, right? 1, 2, 3. Here we've got price decreasing. We're going from 20 to 5, but quantity is increasing. 1 to 4, right? So they're doing opposite things. When you have two variables that are doing opposite things, that's the relationship, the linear relationship, what it's going to look like. Can y'all think of some examples of two real-life variables that have a negative relationship? Maybe the more income you have, what's something that you might do less? Or what's something that you might buy less of? Say again?
Less entertainment.
If you have more, okay, you might go to the dollar theater less. You might go to the regular theater. Or you might, if you won the lottery, if you had a lot of money, you might be able to afford your own home theater and wouldn't go to the movies at all. If the number of hours a college student spends partying goes up, what might go down? Okay, grades. Okay, y'all get the idea. Okay? But positive and negative relationships. So know the definition, know what it looks like, and how to build these graphs. And there are a couple of things that I want to point out to you. I'm going to write this right. I'm going to come back up here and write it right in the middle. In math class, you might remember the equation of a line is y equals mx plus b. And we were using x and y up here in our first example. Who remembers, is y your dependent variable or your independent variable? Okay, this is your dependent variable, because it depends mathematically on all this other stuff, right, to solve it. This one is your independent variable. And usually, when we're graphing in math, we put the y variable up here, or the dependent variable up here, and the independent variable here on the horizontal axis. But in economics, it is switched. Instead of x and y, we have price and quantity, at least in the graphs that we're going to be looking at in Chapter 4, price and quantity. Now remember how I was asking you about t-shirts over here? If the price is 20, how many can you buy? If the price is 5, how many could you buy, right? So when we're talking about price and quantity, which one is the dependent variable? Or what were y'all answering me with? Quantity. How many t-shirts you're going to buy depends on the price that I was giving you, right? So you're just going to have to remember this, that it is switched in economics. It's just because of convention. Price in economics is the independent variable. The quantity of how many you're going to buy, or when we talk about supply, how many you're going to sell, is going to be your dependent variable. That is dependent on the price. And it's not too bad to remember if you can just remember what I asked you about. How many t-shirts can you buy if the price is $10? Everybody's in good shape with that? Okay, so just remember, when we're talking about supply and demand, this is actually going to be a demand curve. We'll see in Chapter 4, but the quantity that you buy or sell is going to be dependent on the price. The price is going to be independently determined by the market. Again, we'll talk about that more in future chapters. Okay, another thing I'd like for you to write in your notes is ceteris paribus. Does anyone happen to know what that phrase means? It's Latin. That literally means all else equal, or that everything else is staying the same. Remember when I was asking you about how many t-shirts you would buy if they were different prices? We had a lot of assumptions in place when you were answering me with these numbers up here. I asked you, if the price went down to 10, how many could you buy? All you were doing was thinking about the price and the quantity, right? You were ignoring your income. You assumed that that stayed the same. We were assuming that wherever you're buying your t-shirts had enough t-shirts in stock. We were assuming that they had enough t-shirts that you liked, right? We assumed that you didn't win the lottery and you were only going to wear Ralph Lauren polo shirts instead of regular t-shirts. We assumed that you didn't move to Alaska and not need t-shirts, you would need long-sleeve shirts. We assumed all these things stayed the same, right? So when you see this phrase on a test question or your homework, that means ignore everything else. You're going to pretend that it all stays the same and you're only going to pay attention to the variables that are in the problem. Because in real life, any of that stuff could happen, right? But they'll run out of t-shirts. And even though they're $1, you can't buy any because they're out. And they're going to have to reorder. Or they don't have your size. So any of that stuff could happen in real life. But for problems in this class, when it's a ceteris paribus, you're going to pretend that everything else is staying the same. That it's all going to be equal. One more thing that I wanted to point out. I'm going to rebuild our t-shirt graph over here. Okay. Remember, this is price per unit over here on the vertical axis. That means price per t-shirt. Now, when we're talking about quantity down here on the horizontal axis, that's total. So you're just going to have to remember that. And I think our data before showed that at $20, you could buy a total of one shirt. At $10 per t-shirt, you could buy a total of 2. And at $5 a shirt, you could buy 4. That was our line graph there. It's actually our demand graph. What's the only thing that changed from this point A to point B? What changed?
The quantity.
Okay, the quantity demanded changed because of the price. The price dropped. Okay, when we're moving from point A to point B, or it could be point B to point A, that's called a change in quantity demanded. And it's caused by a change in the price of product itself. Okay, I'm going to redraw our graph over here. This is price again per t-shirt. These are our original points. Okay. Well, let's get more specific. Let's pretend that these are Dallas Maverick t-shirts. And the Dallas Mavericks has just won the NBA championship. Okay, so are people going to be really excited about buying Dallas Maverick t-shirts and jerseys and all of that stuff after they've won? Why? Because it's cool to have stuff from a winning team, right? At $20 for a t-shirt, are people going to be buying more Dallas Mavericks stuff? Dallas Mavericks t-shirts? Yep. Okay. So I'm just going to draw a point out there that represents a rightward shift from that point. At $10, are they going to be buying more Dallas Mavericks stuff? At $5? Yes. Okay, my point is, after a team wins, when it's really cool to have their stuff, people aren't going to care that much about the price. They just want the product, right? And so at every price, when people want more of the product, this is what happens to our graph. The whole thing moves. See here, we were just moving along the line, right, from point A to point B. That's because it was cheaper and you can buy more. Here, something happened, right? We could be talking about tomatoes. If a news report comes out that says tomatoes will cure cancer, if you eat tomatoes every day, you will never get cancer. People aren't going to care about the price. They're just going to want more tomatoes, period, at every price, right? And when a team wins, it's not price that they're responding to. It's a change in their preferences or their tastes. And so when the price changes for a product, this happens. When something else changes, maybe they have more money. Maybe their favorite team won. Maybe, y'all remember last year, people got sick. Some people died from eating cantaloupe because it has some listeria virus. So it could be the opposite way too. It can be a leftward shift. But when we're seeing something big change, that's called a change in demand. That's the terminology for what's happening in the second graph. And this is caused by, and I'm just going to put something big other than price. For example, it could be income, it could be consumer tastes, or expectations, how many people that we have. But y'all see the difference. We're going to revisit this concept, but I want you to at least have it in your notes because it's very easy for students to get mixed up between this answer choice on a multiple choice question and this answer choice. Quantity demanded versus a change in demand. It's just, the wording's almost the same, but it's talking about two different things. Everybody's in good shape with this? Okay. Great. That is the end of the section on the appendix to Chapter 2, our graphing review.